Howdy, 7th grade. Today we are going to be looking at prime numbers, what they are, and how to figure them out. So if you didn't know, just to do a quick definition, a prime number is going to be a number that can only be divided by itself or the number 1. So an example of that, I'm going to do 5, and 5 is a prime number because no matter what I divide 5 by, it's not going to come out even, except for 5 divided by 5, which is 1, or 5 divided by 1 is 5. So 5 is prime because no matter what other number I pick, it's just not going to work. Conversely, or the other way around, is going to be a composite number. Composite has an E at the end. And a composite number is going to be a number that can be divided by something. By a number that is not itself or 1. So my example here is going to be that 4 can be divided by 2, and because 2 is not 4 or 1, that means 4 is composite. So something I like to do to figure these out, and that I think we already know how to do, is some factor trees. So we are going to make some factor trees real quick. How to factor tree. It's going to be something that's very important. So big thing in factor treeing is we're going to start with a number. I'm going to start with 100. And all we're going to do is we're going to ask ourselves, what can we divide that number by? And I know I can break 100 into 10 times 10. And so I'm going to write those numbers underneath and draw the 2 arrows, and that's going to be because 100 equals 10 times 10. But I can break down the 10 some more, because I know that 10 is 5 times 2, because 10 equals 5 times 2. And I can do the same thing over here with the 5 and the 2. Now we already said that 5 is prime. 2 is also prime. Once you're left with only prime numbers at the end, then you are done with your factor tree. And I can say the prime factors of 100 are, I'm just going to go across the bottom here, 5, 2, 5, and 2. We're going to do one more of these just so I can make sure that we are in the right place. And that is going to be 24. Let me switch colors real quick. So I'm going to break 24 down. And when I think 24, I'm thinking 8 times 3. So I'm going to put an 8 and a 3 down. And then this 8, I'm going to say is 2 times 4. And this 4 here is 2 times 2. So I broke down my 24 because I knew it was 8 times 3. I broke down my 8, it's 2 times 4. Broke down my 4, it's 2 times 2. I can't do anything with the 3, can't do anything with the 2, and can't do anything with either of these 2's. So those are the numbers I have left. So I'm going to say my prime factors are 2, 2, 2, and 3. I got one more thing to show you all about primes, is that we can check prime numbers by making rectangles. So for example, I can say that 6 has 6 rectangles. So I start with 6 rectangles. Sorry, not rectangles, squares. I want to make rectangles with them. So if I take 6 squares, I've got 1, 2, 3, 4, 5, 6. And if we look, I just made a rectangle. It is 6 squares by 1 square. But I can make a different rectangle with those 6 squares. And what that's going to look like, let me divide this up. So I would have 1, 2, 3, 4, 5, 6 squares into a rectangle. So the gist is that if you can make more than one rectangle, with a number of squares, that number is composite. And just like that, I am done for the day. I hope to see y'all tomorrow. Have a wonderful evening. Make sure we do the practice set. And I will see y'all tomorrow. Toodaloo.